Hello everyone, today I'm gonna explain the EGR system combined with a turbocharger, a powerful combination often used in modern engines to improve performance and reduce harmful emissions. This technology is especially important in diesel engines, but it's also used in some gasoline engines. I'll walk you through each component, its function, and why this system is so crucial in today's automotive industry. Let's start with some basics about why we even need these systems in engines. As engines burn fuel, they produce several emissions, including carbon dioxide CO2, hydrocarbons HC, carbon monoxide CO, and the nitrogen oxide NOx. Among these, NOx gases are particularly harmful because they contribute to air pollution, smog, and respiratory issues. NOx is primarily produced when the combustion temperature is very high. This is a big challenge, especially in diesel engines, which tend to run at high temperatures and pressures. To meet stringent environmental regulations, automotive engineers have developed various methods to reduce these pollutants, and the exhaust gas recirculation EGR system is one of the most effective solutions for controlling NOx emissions. So the question is here, what is the EGR system? The EGR or exhaust gas recirculation system works by redirecting a portion of the engine's exhaust gases back into the intake manifold. By recirculating some of these exhaust gases, the EGR system helps lower the oxygen concentration in the combustion chamber. When there is less oxygen, the combustion temperature decreases, which in turn reduces the formation of NOx gases. Lower temperatures mean less NOx is produced, which is essential for reducing harmful emissions. But there is a bit of balancing act here. If we introduce too much exhaust gas back into the engine, it could reduce engine efficiency and the power output. That's why the EGR valve plays such an essential role. The EGR valve precisely controls the amount of exhaust gas recirculated, ensuring that the right balance is struck between reducing emissions and maintaining performance. Another question is here, what is the role of turbocharger? Let's talk about the turbocharger. The turbocharger is a key component for improving the efficiency and power output of the engine. It essentially allows the engine to breathe better by increasing the amount of air, specifically oxygen, that enters the combustion chamber. Here is how it works. The turbocharger has two main sections, the turbine and the compressor. Exhaust gases leaving the engine flow through the turbine, causing it to spin. This spinning turbine is connected to the compressor, which draws in fresh air, compresses it, and forces it into the intake manifold at a high pressure. By compressing air, the turbocharger increases its density, meaning more oxygen molecules are packed into the same volume. This allows the engine to burn more fuel and produce more power without needing to increase its size. Essentially, the turbocharger improves the engine's power and efficiency by using energy from the exhaust gases, which would otherwise go to waste. So, how the EGR and turbocharger work together? Now that we have a basic understanding of EGR and turbocharging, let's talk about how these two systems work together in the setup you see in this diagram. Air intake and compression. Fresh air enters the system through the intake, as you can see on the left side of the diagram. The fresh air is drawn into the turbocharger, where it is compressed. This compression increases the air density, providing the engine with more oxygen-rich air for combustion. After compression, the air becomes hot. Hot air is less dense, which would reduce the engine's efficiency, so the compressed air flows through an intercooler. The intercooler cools the air, making it denser again and allowing even more oxygen into the combustion chamber. The EGR system then comes into play. Some of the exhaust gases, which would normally exit the vehicle through the exhaust pipe, are rerouted by the EGR valve and mixed back into the intake air before it enters the engine. The EGR valve is precisely controlled to allow only a specific amount of exhaust gas to re-enter the intake. Ensure that the mixture entering the combustion chamber has just the right balance for effective NOx reduction. By blending the cooled, pressurized fresh air with a small percentage of exhaust gases, the EGR system lowers the oxygen concentration in the intake. This leads to a lower combustion temperature, which significantly reduces NOx emissions. So, now we have an engine that is not only runs efficiently, but also meets strict emission standards. There are additional components, orifice plate and the digital manometer. This diagram also shows an orifice plate and a digital manometer. These are additional components used for monitoring and controlling the flow and the pressure of gases in the system. The orifice plate is used to measure the flow of exhaust gases being recirculated. It creates a slight pressure difference which can measure to determine the flow rate of the exhaust gases. Accurate measurement of the exhaust gas flow is crucial because it ensures that the EGR system is operating within safe and efficient parameters. The digital manometer measures the pressure in the system. By monitoring pressure levels, we can ensure that the turbocharger and the EGR system are functioning properly and efficiently. If the pressure is too high or too low, it may indicate a problem in the system, such as blockage or a leak, which could affect the performance and the emissions. This combination of EGR and the turbocharging provides a range of benefits, both for engine performance and the environmental impact. First one, enhanced fuel efficiency. The turbocharger allows the engine to produce more power from the same amount of fuel, which can improve fuel economy. This is particularly important in diesel engines, where fuel efficiency is a high priority. Second one, reduced NOx emissions. The EGR system lowers combustion temperatures, which reduces the production of nitrogen oxides. This helps the engine meet strict emission standards set by environmental regulations without sacrificing too much performance. Third one, increased power output. The turbocharger boosts engine power without increasing engine size. This allows smaller engines to achieve the same power output as larger engines, which reduces weight and improves fuel economy even further. Fourth factor is better overall engine performance. By working together, the EGR and turbocharger provide a balanced solution that allows for both high performance and low emissions. This combination makes modern engines both powerful and environmentally friendly, meeting the needs of both consumers and regulators. However, combining EGR and turbocharging does come with some challenges. First, complexity of the system. Adding an EGR and the turbocharger increases the complexity of the engine. This requires more precise control systems, maintenance, and sometimes specialized parts which can raise costs. Second, increased maintenance needs. EGR system can cause a build-up of carbon deposits, which may eventually clog the valve or intake manifold. Turbochargers too require good lubrication and regular maintenance to prevent wear and tear. Third factor, temperature and pressure management. Because the EGR system reduces combustion temperature, it can potentially reduce the engine efficiency if not properly managed. The turbocharger helps counteract this by boosting air intake, but careful calibration is needed to ensure optimal performance. Looking to the future, many manufacturers are finding new ways to improve this system. For example, variable geometry turbochargers can adjust the flow of exhaust gases more effectively, allowing for even better performance. Additionally, advanced EGR systems like low pressure EGR are being developed to further optimize emissions and efficiency. In conclusion, the combination of an EGR system and a turbocharger represents a sophisticated solution to meet both performance and environmental requirements in modern engines. It allows vehicles to deliver powerful performance while also adhering to strict emissions standards. This is why EGR and the turbocharging have become integral in the automotive industry today, especially in diesel engines and the high performance applications. Thank you for listening, and I hope this gave you a comprehensive overview of how EGR and the turbocharging work together to create more efficient, environmentally friendly engines. Thank you.